Episode of LeetCode. And for this episode, we'll be doing the remove k digits problem. So given a non-negative integer num represented as a string, we want to remove k digits from the number so that the new number is the smallest possible. And we're also given two other conditions. The length of num is less than 10,002, and num is greater or equal to k. And we also know that num does not contain any leading zeros. And they also give us three examples. So in the first example, we see that k is 3, so we want to remove 3 digits. And here we remove 4, 3, and 2. And then we get 1219, which is the smallest num possible. And in the next example, we only remove 1 digit. So the obvious choice would be to remove the leading 1. And this gives us a leading 0, so we want to remove that too and return 200. And finally, we also have an edge case where k is 2, so we want to remove all the digits in num, and in that case we just return 0. So how do we start this problem? Well, there are several intuitions that we can keep track of, and the first is that it's best to start removing digits from the left, because the left digits are more significant than the digits on the right. In other words, removing the 1 creates a smaller number than removing something like the 4. Next, we want the numbers to be in non-decreasing order. And if you think about this, if we have a number 1, 2, 3, 4 versus 1, 4, 3, 2, 1, 2, 3, 4 is non-decreasing, whereas 1, 4, 3, 2 isn't. And we see that 1, 2, 3, 4 is less. And this is true for all natural numbers. And it's just a formal intuition that you can see from the problem. And so from these two intuitions, where we want to remove digits starting from the left, and we also want this series of digits that aren't removed to be non-decreasing, one thing we can use is the stack data structure, which allows us to keep track of the more recent numbers if we iterate through the string from left to right. So the first thing we want to use is a stack. Now, if we iterate through the stack of characters, we can first create a for loop that iterates through all the elements of num, and then we have an inner while loop. And for this while loop, we need a condition. So the condition for this while loop, and so first let's talk about what the while loop will do. For this while loop, we want to remove all these large digits that prevent us from having a non-decreasing order. So let's say I have a bunch of digits so far, and then I have a new digit, x prime. And in order for this sequence to be decreasing, x, y, z, they all have to be less or equal to x prime. So this would be the condition for our while loop. And if this condition isn't met, well then we want to remove all these numbers that are greater than x prime. For example, if y and z are greater than x prime, to maintain the non-decreasing condition, we want to create a stack that only contains x and x prime in that order. And we would do this by removing z and y, which would be at the top of the stack. And if you remember, a stack is last in, first out, which means that if we first insert x, it will be at the bottom of the stack, then we insert y, and we insert z, 0 will be at the top. So then we first pop z, and then we can pop y. So these are gone, and then once we do that, we can push the newest element, x prime, onto the stack. So now writing this in code, the main condition that we said was that x prime has to be greater or equal to all the previous digits. So then the inverse of this would be if it's less than the digits. So x prime would just be the character at index I, and then if this character is less than the top of the stack. So the stack has a function called peek in Java, which allows you to do that. And then once we do that, we want to pop the top of the stack because this can, in order to meet the condition. And then we want to subtract k by 1 because we have removed one digit. So naturally, once you have k, you want to keep track of other conditions, which includes making sure that k is positive, because once we've removed k digits, we are done, and there's no need to remove more digits. And another thing we have to make sure is that the stack is non-empty. And this is because if you have an empty stack, you can't really remove anything from it. You can only add to it. And then once we are done removing it, we have ensured that we have maintained this non-decreasing condition, and we are able to safely add this so-called x prime character to the stack. And in this case, it would be num.car at I. Next, we want to check for an edge case. And this edge case is if we haven't removed enough digits. So say for example, we had some sort of number like 1, 2, 3, 4, 5, 6, right? And this number in itself is already non-decreasing. So here our k would still, let's say k was 3. After going through the first, iterating through all the elements, k would still be 3 because the sequence was non-decreasing and there was no need to pop any elements from the stack. As a result, but we still have to remove 3 elements. So which 3 elements would be most logical to remove? Well, they would be 4, 5, and 6, or essentially the last 3 elements of num, or the top 3 elements of the stack. So this is what we're going to do. So while k is greater than 0, we want to pop the top element from the stack and subtract the k count by 1. So once we have done this, we have created a stack which has size of length minus k. And once we have done this, we know that this stack contains an order of non-decreasing integers. And once we have done this, now we can use a string builder to efficiently rebuild the string. And because of the property of the stack, when we rebuild the string, it will be in reverse order. So now we're just popping elements off the stack and appending them to the string builder. And the string builder is generally the most efficient way to concatenate strings or characters. So once we have done this, there's one final step that we have to do, which is to remove all the leading zeros, if there are any. And naturally, because of the way the stack was built, the zeros would have been at the bottom of the stack. For example, it would have been something like 0, 0, 1, 2, 3. And then if we pop the stack, then we would have gotten 2, 1, 0, 0 as the string. But the actual number would have been 0, 0, 1, 2. So essentially what we want to do at this point is remove all the zeros, which happen to be at the end of this string. So to do that, and this is actually a more efficient approach than, say, first reversing it and then removing the leading zeros, just because of the nature of the string builder. So we want to remove the zeros when they are at the end of the string builder. So we can do this by using another while loop. So while the last element of the string builder is 0, we will keep on removing it. And then there's another condition that we have to check here, which is that the length of this string is greater than 1. This is because even if the last remaining element was 0, we don't want to remove the 0. So once we have done this, we have essentially pruned 2100 into 21. And but the actual number that we want is 12 as a string. So all we have to do now is return the string in reverse order. And you can do this using the reverse method and calling toString to return the string version of the string builder object. And so now there's one final condition that we have to check, which was given to us in example 3, which is when you remove all the digits of the number. And so we have to check for this large edge case, which is very simple. So, and this is basically when k equals to the length of num. And for this case, we want to return 0. And so now we are done. And if we run the code, it should work. And so it works. So that's it. Hope you enjoyed this video.